Welcome to Colonize the Ocean podcast, where we discuss oceanic colonization, exploration, and education with your hosts Adam Jewell and Brendan Traxler.
Welcome to the deep dive. Today, we're plunging into something really quite cool. It's an underwater habitat project.
Yeah, this is from a Danish company, SAGA Space Architects. We've got a great report here, actually, from DTU Compute.
Okay.
It covers the unveiling of their sort of experimental habitats and the buzz it created at the Technical University of Denmark, DTU.
Right. So our mission today.
Let's dig into the details, figure out what this is all about, and, what the potential really is here.
Sounds good. So if you're into space or maybe cutting edge tech or just how humans handle extreme places.
Yeah, this should be right up your alley. It's got a bit of everything.
Okay, let's jump in. The big picture, the ultimate goal for Saga, seems to be this thing called UHB-3, set for 2027.
That's the target, yeah. UHB-3. And its main job, it's basically astronaut training.
For EASA.
Exactly, for the European Space Agency. Preparing crews for, future moon missions. It's about simulating that deep isolation, the tricky living conditions they'll face.
And they plan to do this 30 meters down.
30 meters underwater, yep.
Wow, that's deep. That really drives home how extreme this is.
Yeah.
The report mentioned some clever design features for UAB too.
Oh, yeah, definitely. Like the water lock. The illustration shows it in the floor.
Which makes sense because of the pressure, right?
Precisely. The water pressure actually helps seal it. And windows are a weak point structurally.
So no scenic views.
Well, not through glass anyway. They're planning artificial windows, basically screens, showing live feeds from cameras outside.
That's a smart workaround.
Mm-hmm.
Really shows the kind of thinking needed here. Okay, so before UHB-3, they showed off UHB-1 and UHB-2.
It did, yeah, at the Digital Tech Summit. It was a great chance for people to see them. About, 4,500 visitors got a look?
Okay, so UHB-1.
UHB was pretty small, a one-person habitat. They had it inside the Exon Island venue in Copenhagen, kind of like a personal pod.
A glimpse of solo deep living. And UHB-2, that sounded bigger.
Much bigger. It was outside, a full-on 40-foot shipping container, completely kitted out.
Kitted out how?
It had a lab, a living room area, sleeping cabins, designed for 4 people to stay for up to 30 days.
30 days. Okay, that really gives you a feel for the scale.
Definitely. You could really see the long-term living potential there.
And seeing that must have really caught the attention of the folks from DTU. The report says they were pretty enthusiastic.
Oh, absolutely. DTU's provost, Rasmus Larsen, and the head of DTU Compute, Jan Madsen, they both checked out the exhibition.
And they saw research potential.
Loads of it. Larsen apparently called it technology for people, which is a nice way to put it.
What specific things caught his eye?
Well, the obvious engineering challenges, for one. The actual construction, interesting detail, they're using 3D printing for some parts.
Really? Okay.
Yeah. And then managing the inside environment, that's huge. Temperature, humidity, even special lighting that follows, like a natural day cycle.
Circadian rhythm lighting.
Exactly that. Helps with sleep and stuff. And doing all this energy efficiently underwater. Plus, the whole human side.
How people cope living together in a small space.
Right. How they work together, stay productive, all that. These are big research areas for DTU.
It's amazing how many different factors are involved.
Yeah.
And DTU Compute, specifically, they were excited about the data.
Oh, yeah. Jan Madsen pointed that out. You monitor the habitat and the crew 247. Think about the sheer amount of data you generate.
A continuous stream.
Right. And their department is all about processing and analyzing big data sets for health, climate control, energy use.
So the habitat becomes a kind of underwater lab generating data constantly.
Pretty much, yeah. A living lab. And Madsen also mentions something new for them, underwater communication.
How to talk to the surface.
Yeah, using sonar, using radio signals underwater. That's a whole new research area for them, but obviously vital for the habitat.
Absolutely critical. Now, something else that jumped out was the defense connection. Rasmus Larsen wears another hat, doesn't he?
He does. He's chair for the National Defense Technology Center's steering committee. That involves all the Danish universities working on defense tech.
And he sees a link here.
A very clear one. He talked about dual use potential.
So it's not just for astronauts.
Not at all. The conditions inside, that isolation, that pressure, it's actually a pretty good simulation for defense personnel who might have to work in really tough places.
Like the Arctic, maybe?
Like the Arctic, yeah. But also, think about the habitat itself. You could potentially use similar underwater structures
For what? Surveillance?
for monitoring, keeping an eye on critical underwater infrastructure, maybe near pipelines or cables, using sensors and tech to watch for anything unusual.
So space training, scientific research, and potential security applications, that's quite a range.
It really is. It shows how this kind of controlled, extreme environment can be useful in ways you might not expect at first.
Okay, so what's the timeline for UHB-2? When does it actually get put through its paces?
Well, Nicholas Monk Anderson from SAGA said it still needs full construction, then really thorough testing, lots of checks.
Understandable.
The plan, though, is to ship it off to IAK's Astronaut Training Center, that's in Cologne, Germany.
And when would that be?
They're aiming for around the end of January, maybe February of 2025.
So, coming up pretty soon, actually.
Yeah, things are moving quickly.
And the team making all this happen, SAGA Space Architects, what's their story?
They're a really mixed group. Architects, sure, but also engineers, designers, software people. You need all that expertise.
Right, it's not just drawing pretty pictures.
Definitely not. And they handle everything themselves, apparently. Design, building, testing these extreme environment structures.
Yeah.
All in-house.
Impressive.
And we know the co-founder, Sebastian Aristotelis, he gave the DTU folks the tour in the presentation.
Okay.
And the other architect, Nicholas Monk Anderson, he's the one focused on getting UHE-2 through all its testing right now.
Sounds like a dedicated bunch, and
Yeah.
projects like this need backing, right?
For sure. The exhibition at the Digital Tech Summit, that got support from the Beckett Fonden and also Innovation Fund Denmark.
So recognition and, importantly, funding.
Yeah, which shows there's real belief in what they're doing.
Okay, so let's wrap this up. This deep dive into SAGA's underwater habitats, especially looking ahead at UHB-3, it's clearly a massive undertaking.
Huge.
More than just getting ready for space. It opens doors for all sorts of underwater research and even these defense angles we talked about.
Yeah, the insights you get from studying people and tech in this kind of extreme place,
Yeah,
they could ripple out quite widely.
absolutely. Which leads to maybe a final thought for you, listening in.
Yeah, think about the parallels. Living and working down there, isolated, under pressure. How different is that really from other extreme situations? Or even, some aspects of our modern lives, connected all the time, maybe isolated in other ways. What lessons from down there in that specific extreme could actually teach us something useful about, well, completely different challenges, something to chew on?